if you did not, did anybody not grab either the percent composition sheet or the new assignment schedule when you came in today? I promise you there will always be something. Always. Here we go. All right. So I just want to first go over some of the things on the assignment sheet that are coming up in the next few days here, and just a couple reminders as the semester winds down. So next week, Thursday, it's the last day of the semester. Okay, we're not having a traditional exam or anything like that. Okay, or anything like that, but you need to have all your work in by that day. Okay, that includes that's late work, extra credit, any of that stuff needs to be in by next Thursday. If you come in the following, like what is it, Tuesday, we don't have school Monday, and you're like, well, I wasn't here Thursday and I have extra credit now. Like, it's too late. Okay, it's got to be in by that Thursday. So if you know you're going to be gone next Thursday, if you think there's a possibility that you might be sick on Thursday, get it in on Wednesday. Okay, like it's no questions asked. Okay, so on your assignment schedule there, where it says on the homework due column, where you look down, it's Thursday 121, right on there, please. Last day for extra credit, last day for work. Whatever you need to write in there to remember that that's the last day. So it's literally right here. Okay. Looking at the schedule. List of things that are coming up right now. So today we're going to be doing percent composition. Bubblegum activity we used to do with everybody. We're just going to have one person volunteer today and do that. We're going to do the either or pre-lab. Tomorrow you're going to watch a Modern Marvels DVD. It's going to show you the real world scenario of what you're doing in lab on Friday and Monday. Okay, so we are not going to be here tomorrow. None of us will be in our small groups tomorrow. So myself, Mr. Gussie, or Black, or any of the other science teachers. We have a science department meeting tomorrow. So you're going to have a sub. Any of your classes are going to be watching that DVD. There's a couple questions to go along with it. You're going to have a lab write-up and a percent composition thing to be working on too. I have no problem with you doing the lab write-up as long as you can pay attention to the DVD as well. My class, if you can't do that, because you're going to have to answer the questions on there too. Okay. Otherwise, Friday then you're going to have the sheet from today due, and you're going to have the pre-lab due on Friday. So you got some things to be working on during PLTs tomorrow. Then Friday and Monday we're doing the lab. Next week Wednesday, Mr. Blackford is going to be giving a lecture on empirical and molecular formulas. We'll finish that up with a plane crash activity that you guys will find out more about next week, and then literally that's the end of the chapter, or not the end of the chapter, sorry, the end of the semester now. After you come back from the short break, we'll have a lab, a couple days of review, and then the following Monday you'll be taking the chemical formulas test. Okay, so it's another Monday test. That's about 3 weeks from now. Okay, so literally February 1st. Questions on the schedule or anything on there at all? Perfect. Then you need to take out the percent composition sheet that you picked up as you walked in. All right, so today, we're going to be talking all about percentages. Okay, so how do we do percentages? First part of the day, we're going to take some percentages using the Packers Redskins game. We just happened. Okay, so we're gonna find out that literally doing a percentage like that is the exact same way. Yes.
On the side, it said there's a good mild on here, so that's correct.
That'll change. It's Friday. Yeah. It's due on Friday. We're going to go through how to do just percentages in general start, and then at the end of today, we'll figure out how to do that with chemical formulas. I need a volunteer to start class. To what? They just need a volunteer. It's nothing bad. One person. Okay. Come on, Mari. What Amari's going to do for us? If you look on the bottom of the percent composition, so the left-hand side where it says mass of gum and sugar, mass of gum, all that stuff at the bottom of the sheet. See that? What we're going to do is, we're going to figure out. Are you chewing gum already, Amari? Yeah. You're going to spit it out. Or you have to choose somebody else.
Amari.
I'll spit it. Fine, there you go.
Okay.
Well, he's going to throw it out.
I bet we beat you guys. I put $5 on it.
So what you gotta do is, you're gonna take this out, you're gonna weigh it right now. So weigh it, yeah, so take it off. Put the paper down and then 0 it out. So what's gonna happen is that Jacob's gonna weigh this out. He's gonna tell us all how much the gum and the sugar in the gum weigh. So we're basically assuming that gum is made up of 2 parts, gum and sugar. Okay, I mean obviously there's other things that make up the gum, but for the intent or purpose of this, we're just gonna assume that it's all gum or sugar. Oh, sorry, I need to plug that in probably to help out. All right, here we go. What he's gonna do then, after he weighs it out, he's gonna chew it while I talk about percent composition today. After I'm done talking about it, he's going to come up, weigh it again, and we're going to find out how much of the gum was sugar, how much was the gum pieces, okay?
So how much is it? 9-1.
Okay,
19.
You got to chew it during class. Okay. Keep your paper though. So we're going to put on there, and I don't want that, your saliva on the scale. No offense.
There's nothing wrong with this one.
Take it easy. Yeah, it's sticky on there. That's what's wrong. Okay? So how much did it weigh? Jacob, how much did it weigh?
7.9.
7.90. So everybody, where it says mass of gum and sugar, right? 7.90. Okay, now today we're going to talk about just doing a percentage and how we find percentages. And really the generic way to find any percentage is you take the whole on the bottom, you have part on top. So what I mean by part and whole is basically you take the part, or whatever the smaller number is of something, what the part is, and you divide it by the whole. So for example, the very first one we want to do is, what is Aaron Rodgers' completion percentage, and what is Kirk Cousins' completion percentage for this football game? So what we need to do is, the part would be the amount of completions that Aaron Rodgers had. The whole would be the number of times, the number of attempts that he threw during the football game. Does that make sense? That's how we always do a percentage. And then you times it by 100 to get your percentage. That makes sense? So we're going to do a few things with the football game with the box score today, just to show you that how to do percentages. Then we'll do it with compounds and elements. So if you're looking at your data here, this whole thing is a box score from the game. Okay, it shows us all our stats. First thing that we want to look at is Aaron Rodgers. All we're looking at is this completions and attempts right here. So it gives you exactly what you need to know. So the 21 is literally how many completions that he had. And the 36 is how many times that he actually threw a pass. Not how many times he dropped back to throw, because sometimes he gets sacked or whatever, but it's the amount of times that he actually attempted to throw a pass. Okay. I'm skipping a step here. So you take that 21, divided by 36, you times 100, that's going to give you a percentage. So does anybody do it so far? What is Aaron Rodgers' completion percentage in this football game? 58 point anything? 58.3%. So he completed 58.3% of his passes. It's not great, it's not terrible, it's not Cam Newton bad, it's not, Tom Brady good. So whatever, somewhere in the middle. All right. Next one, Kirk Cousins. Same exact thing here. Now we're just looking at, if you don't know who Kirk Cousins is, he's the Redskins quarterback. Okay, we're looking at his completions and attempts here. We're taking the part, the 29, That's his completions. Divided by the whole, that's his attempts. So what was Cousins' completion percentage? Somebody have it? Okay, I don't have these written down, so you're going to have to do something today. Guys, you're going to need a calculator out. I know you all have phones on you, so use it. What do you guys got? Who's got the answer? Raise your hand. Yes. 60 point what? 60.41%. So Kirk Cousins has completed a greater percentage of his passes. Does that mean Kirk Cousins is a better quarterback than Rodgers? Absolutely not. But it's just one stat of football, okay? We're going to do the same thing with a few other statistics from the game. I'm going to help you along with some of the stats. If you know what you're doing, feel free to just do it. The next one says, what percentage of the game's total rushing yards did Eddie Lacy have? Now, I want to know what percentage Eddie Lacy have of the whole game's yards, not just of the Packers' yards. Okay? So, we need to look first at what's the part here that we want to know the percentage for. Eddie Lacy's yards, right? So we got to look at how many yards did Eddie Lacy have. The yards for everybody is in this column. Okay, from here down is rushing yards, from here down is receiving yards. So we want to look at Eddie Lacy's rushing yards. He had 63. Now I need to know how many rushing yards were total in the football game. So I look here. In the middle is the team stats, you guys. So that tells you like how many yards the Packers would have as a team. On the sides are their individual statistics. Okay, so the total passing yards or rushing yards, is right here. Packers had 141. Redskins had 84. Remember, I want to know how many his percentage of the entire game, not just the Packers. So I'm going to take 141 plus 84. 2 1/4. What?
2 1/4.
Right, it's 2 1/4. So it's 225. So we take 63 the part divided by 225 multiplied by 100 would tell us the percentage of the yards in the game that came from Eddie Lacy. So Eddie Lacy accounted for what percentage of yards? 28%. Right. You know, so he had 28% of the total rushing yards in this football game. You know, 5 pounds ago that might have been 33%. 15 pounds ago that might have been, I don't know, 40%. But whatever, it is what it is. Okay, next. I want to know what percentage of the passing offense, this is the Packers passing offense, did James Jones have? So, what you need to do, look at James Jones' receiving yards, and we need to find the Packers' passing yards. So if you look up there, somebody, where can you find out how many yards James Jones had?
Right on his stats.
Right on his stats, which some people don't know what that is, Ryan. So where is that? Right here, right? Right where it says J. Jones, that's his yards. We're going by yards.
Is that a 61?
It's an 81, sorry guys. It's an 81.
Had to make sure.
And the Packers, you can find out their passing yards. Net passing yards tells us how many yards passing the Packers had in the game. So once again, I'm doing the part divided by the whole. The part is James Jones receiving yards. How many yards did he have? Did I say 81? Packers total passing yards was 205, right? And what percent is that?
39.5.
What is it?
39.5.
39.5%. Perfect. So hopefully that continues for the playoffs. Because I got James Jones on my fantasy team for the playoffs. So fantastic. Okay. Next one. What was so some of these are going to be more involved than others. The next one says, what was Rodgers' percentage of the total offense? So you need to do two things to figure this out. First of all, you need to figure out how much total offense did the Packers have. That's your whole. Then what you also have to do is figure out how many yards Aaron Rodgers accounted for. Aaron Rodgers shows up in here in two places. He had passing yards and he had rushing yards. So you can't just look at his passing yards. So we got to figure out how much did he account for and how much did the Packers have overall. Where it says rushing. And A. Rodgers. That's him. So do it.
Okay. It'd be nice to see total offense count.
The offense yards here, I told you the team is right in here. If you're trying to figure it out. Did you guys get her? We're not calling special teams though. Offense is literally just passing and rushing. So use the net passing and use the rushing. Huh? He's not a wide receiver, that's Richard Rodgers. No, that's the tight end for the Bears. It's not there. Okay, so what are we getting? How many yards did Aaron Rodgers account for? 209, right. He had 210 passing yards, but he also had 1 rush for -1. Okay, how many yards did the Packers have total? 346, right. You need to take that 141 from rushing plus a 205 from passing. So 346 total yards. Okay, times 100, and our percentage is?
60.4.
60.4%. I mean, a lot of games that's a lot higher even than that. It means legitimately actually had pretty decent balance in this game. So 60.4% of the total offense came from Aaron Rodgers. Okay, we got 3 more to do. The next one, what percentage of Jordan Reed's yardage was a result of his longest catch? Jordan Reed's the tight end for the Redskins. He's over here on this side. So this LG is long. These yards mean how many yards total he has. So I don't know. What percentage was result of his longest catch? What? It's 24 T. The T means he scored a touchdown on the play. Yeah. You don't do anything special with that. What's up? I know. That's why it's funny. Literally, you read this like, this is catches, this is yards, this is touchdowns, this is his longest. Okay, so somebody, what do we got here? What 2 numbers am I going to use? What's the part? 24. How many total did he have? 120. So the percentage is 20%. So 20% of his total yards came on just 1 play. That's why we don't like to give up big plays. Right, Jesse? Right. All right. Number 6. What percentage of the total points scored were scored by both teams in the second quarter? So this top here, this is literally the box score. It literally tells us how many points are scored by quarter, and it tells us what the total points were for each team in the game. So I want to know what percentage of the points were scored in the second quarter. So that's including both squads. So you can't do running backs or tight end for that one, you guys. Can't do running backs or tight ends. The Redskins, Jordan Reed and Chris Thompson are both running back and tight end. And Alex Smith is also a tight end. And I'm pretty sure you know what the Packers players are. So. Okay, so for this one, what do we need to do first? What's the first thing we had to figure out? Add that second quarter scores, right. So, John, what'd you get for the second quarter scores? 23. Right, 23. And then, what do we have to do after that? Add the final score. So what are the final score? 53. So what percentage of points were scored in that second quarter? 43%. So almost half the points from the whole game were scored in that second quarter. So they got 43%. Very last one, a little bit more challenging. I want to look at both teams. I want to know what percentage of each team's offense came from wideouts and which team had better production from their wide receivers. So wideouts is the same thing as wide receiver. So we got to figure out which ones are wideouts. Okay? For the Packers, it's every single one. The top four, the arrow literally means that's the ones that are wide receivers. Okay? On the Redskins, it's the bottom five excluding the middle one. So A. Smith. Alex Smith is a tight end. And he's a quarterback for the Chiefs. It's amazing. He just flew cross country. It is 48. Yeah. Okay, it's 81, 48, 38, and 14. Just to clarify on the numbers. For the Redskins, it's 70, 17, 15, and 2. Randall Cobb is 38. He's 38. Yeah, he had 3 for 38.
So you guys like that? You guys like my we go to their passing. 2-0. Okay, like the
No, second quarter, not second half.
No, second quarter.
Yes, if it was the second half, it would be.
120. Wait, no, he's not a wide receiver.
Who's not? Jordan Reed's not a wide receiver. Pierre Garçon, Jameson Crowder. That's a basketball player.
70, 17, 6. No, that's Alex.
70, 17, 15, and 2 it is. Deshaun Jackson should say 15 and a touchdown, but he's dumb.
Yeah, I know. Yeah. What's their? Okay, so like he was like, why don't he was like piling right here. Oh yeah, and he's just get his arms in.
That's the rule, though. Okay, so let's throw it back in. For the Packers, what were our numbers for the Packers? How many yards did our wideouts have? 181. Okay. And what was the total offense? Not passing offense, total offense. Huh? That's passing offense. I want to know total offense, yeah. The Packers' offense. Running the ball is offense still. So what was the Packers' total offense? 346, right. So 181, that's the part divided by 346. Don't take any credit away from Eddie Lacy's big rumbling belly down there. You made it. Might not look as pretty as Randall Cobb does, but you know what? We're okay with it. Still counts. All right. Okay, so what was the percentage here? 52.3, right. 52.3%. For the Redskins, what was it? How many yards did their wideouts have? 105. 105. Is it 105 or 104? 104. Okay. I can do it in my head, but here we go. 70 plus 70 plus 34. It is 104. 70 plus 34. Okay. Okay. Anyways, what's the total offense the Redskins had? Was it 354? They were that close. Wow. Redskins had 354 total yards. We take 104 divided by 354 times 100. What's the percentage? 29.4. All right. So, whose wideouts had better production? Huh? Packers. You better hope it looks like that against the Cardinals this weekend, because that's about what we're going to need to do to win that football game, to be honest.
3 times.
All right. So, when we do, that's all we're going to do with Packers. Now you're like, why did we do that? Gentlemen. Thank you. I'm just trying to show you and do something other than, chemistry to do percentages, because we're going to use the exact same concept when we do, ladies. Thank you. Gentlemen. Thank you. When we do percent composition for compounds, we are going to use the exact same principles, okay? So we're just going to take the part divided by the whole. So basically what we're going to be doing, and we'll get to the bubble gum in a second, is we are going to take a compound like CO2. We're going to find out what percentage of its mass comes from carbon, what percent comes from oxygen. So we're going to do it the exact same way. We're going to take the mass of carbon divided by the mass of the whole. We'll take the mass of oxygen, divide that by the mass of the whole. Okay, so it's the exact same way that we just did it, but we need to do, Jacob, we need to do the mass of the gum right now. So we're going to find out how much of that gum is sugar and how much is other parts, gum. I don't know what's in gum, I'm not going to lie. So we'll call the whole thing gum. You got the wrapper still? Fantastic. What was the mass from before? 7.9. Okay, so 7.90 grams. Throw that on there. Make sure you hold on. Take it off there once and zero it out first. So take this off of the wrapper. Now put the wrapper down so it doesn't cover the mass. Oh gosh. I'm saying zero it out. Yeah, there you go. Now put the gum on. What is it? 2.19. Okay, so it's 2.19 grams. You can the garbage are outside. Think about that. First of all, it's disgusting because that thing still has like literally saliva in it too, so it's probably actually weighs less than that, just the gum. But for whatever, we'll say it's 2.19 grams. Okay, that's the mass of the gum only. To find out the mass of the sugar, then, so how much sugar Jacob was actually able to literally chew out of that thing. Sorry, it's kind of gross a little bit. But you take 7.9 minus 2.19, so that's going to be what? 5.69? 7.1. That's right, 7.1. 5.71 grams. Okay? So, same principles apply that we just did. We want to find out how much percent that gum was sugar and how much percent it was gum. So, we're going to take the part divided by the whole here to find these percentages. So you literally take 2.19 divided by 7.9 and 5.71 divided by 7.9. So what percent is it gum? 27.7. Okay. And then how much is sugar? 72.27. 72.3. 72.3% of bubblegum is sugar. That's why you probably loved it when you were a kid. And you may bounce off the walls afterwards. It's fantastic,
Talk about the answer.
That's what I do when my little cousins come over and just feed them sugar. And I'm like, all right, Mom and Dad, here you go. Teach you to have them babysit for them.
The mass of the gum.
No, that goes to percentage. All right, ladies and gentlemen, we are not done, not even close right now. I am going to show you how to do percent composition with compounds. So we just have two examples that we're going to do, and then I'm going to go through the either or lab with you. We might have a little bit of time at the end to start working a little bit. So you can write this on the back of your sheet, on the bottom if you have space, either one. Okay, percent composition. It's very straightforward. It's as straightforward as taking the Packers stats was. Okay, so the first thing that we're going to do is we're going to find the total molar mass of the compound. Now to do this, what I would do is I would first write out, because it's not going to be this obvious every time, I'd write out S and O and literally count up how many atoms you have of each one. Obviously in SO2, it's going to be pretty straightforward, right? But it's not always that easy. So in SO2, sulfur dioxide, there's one sulfur and two oxygens. The next thing that we need to do is we need to figure out how much sulfur and oxygen weigh in molar mass from the periodic table. So we look up, we see sulfur is 32.066. If you want to do all these right and get the correct answers always, round at the end. Okay, so we do too much rounding in the middle. Yes, it's going to require you add a couple extra numbers. You're going to be okay. You won't get arthritis yet, I don't think. Okay, for oxygen, it's 15.99 for the molar mass. 999, I'm sorry. Now, what we need to do is, we got to multiply, okay, 1 by 32.066, which we know is obviously just 32.066. But we also must take oxygen, there's 2 times 15.999. So it's going to be 988? All right. 31.988. So when we do it like this, we already know the mass of each part. What all we need to find right now is the mass of the whole. So we need to add those two masses together. So the total molar mass of this compound is 64.064 grams per mole. Okay, now to find out what percentage sulfur and what percent oxygen, we need to take the part divided by the whole. So the amount that's sulfur is literally 32.066 grams of sulfur, so we take the 32.066 and we divide it by 64.064. So I can just write a line like this, 64.064. You're going to times that by 100. That's going to give you your percentage. You do the same thing with oxygen. Divide by 64.064. Sorry. Now I'm just going to stand right in the middle so nobody can see. Okay.
Well, you're just multiplying the 64.64 by 100?
You multiply the answer by 100.
Yeah.
So you take 30, yeah, it doesn't matter the order that you do it. You multiply by 100 to get into a percentage. To get it out of the decimal form.
That's what I'm sure.
You've done percentages before.
I think I understand.
Good. Okay, so for the top one, for sulfur, you should get 50.05%. And for oxygen, you should be getting 49.95% oxygen. Does anybody have questions on that first example or how to do percent composition? We're going to do one more challenging example next. That's all we're going to have for percent com stuff. No? Okay. The next one that we're going to do is aluminum sulfate. So for this one, just like before, we're going to start by counting out the total number of each atom. So I'm just going to write Al, S, and O. How many aluminums are in this compound right now? 2. Sulfurs. This is where some people might get confused. This 3 needs to be distributed by all 4 oxygens by the sulfur. Okay, so there's 3 sulfurs here. Then I need to figure out how many oxygens I have. So how many oxygens are there? 12, right? It gets distributed through. So you multiply the 3 times the 4, you get 12 oxygens. Now we need to find the molar masses from the periodic table, multiply them by these numbers. So aluminum's the only one that we didn't write down already. It's 26, and we'll do 26.982. So we'll round that last one. We know from before sulfur is 32.066. and oxygen is 15.999. Okay, what we need to do next, we need to multiply them out and add them together. So for aluminum, we're going to get 53.96. Sulfur, you're going to get 96.18. And for oxygen, you're going to get 191.988. Add them up and it's going to give you the total molar mass of the compound. So that's 342.128. All right. So what do I need to do next? What do I do with these? Huh? Divide them by 342. Exactly. 0.128. So I divide each of them by 342.128. I'm taking the part, dividing it by the whole, just like we did before. And that's going to give me my percentage here. So first, how much percent aluminum is in this compound? Somebody got?
15.7.
I got 7. So 15.77. The sulfur is 28.11. And the oxygen is 56.12%. Okay, you know that you did it right if these are close to 100%, right? And you might have rounded, maybe you didn't get exactly 100% right in the head, but it's got to be extremely close to 100%. Like if you're 5% off, you probably did something wrong. You know, if you're more than that off, you definitely did something wrong during the problem. Okay, so that's a way that you can check your work, check your answers when you're done. All right, does anybody else have questions on the percent composition? Yes, no, maybe? Okay.
So this sheet is our homework.
Yes, that's due Friday. But I'm going to give you the lab right now too, okay? So the lab.
These rounded up
All right. So, take a look at the lab sheet that you're getting right now and go through a few things and what is expected of you for this lab.
Don't throw
1.
Okay. So if you look at your lab sheet. Sorry, you guys still getting them right now? Okay. I will wait. Okay. So look at the sheet. Everything with an asterisk. You know what an asterisk is? Okay. It's a little star. Okay. Just checking, okay? Everything with the asterisk, that's what needs to be in your lab notebook, and it needs to be in there by Friday. Okay, so you need to have the situation, so the intro and the materials, the safety, the pre-lab questions, the lab procedure, which is relatively short for this, and the data table. That has to be in your lab notebook when you come to class on Friday. Okay, so you have two things that you can work on during PLTs tomorrow. It's the percent composition sheet, and it's getting this in your lab notebook. Okay? Now, the situation for the lab. Basically what we're going to do is, you are tasked, you're basically working for this mining company, and your mining company is deciding to mine for copper from one of these two sites in Guatemala. What? We're not actually going to Guatemala this month, right? So, what we need to do is, we need to figure out which soil or which site in Guatemala has more copper by percentage. Makes sense. So we want to go mine at the one that has a greater percentage of copper. Now, this is what Guatemala looks like. Okay, so we can't just bring our whole team in there to start out with. We're not going to bring all our equipment to the wrong site that has less percentage. So basically, we're sending you in to determine which site we'd like to go mine at. Okay, or which site is going to be better for the mining operation. So what you're going to be doing in the lab, you're going to get a little sample of, it's going to be basically a soil sample. Okay, you're going to be leaching out the copper from that sample. So you're going to be separating the copper that's in that soil from everything else there. Okay, you're going to get rid of it, you're going to filter it out, and you're going to figure out, okay, which soil has the most copper by percentage or by the mass percentage, basically. What you're going to find out. So you'll weigh the soil first, you'll weigh the copper that you get to end. Whichever one's higher, that's the site that you're going to send your company to go mine it. This is a very real world application. The Modern Marvels DVD that we're going to watch tomorrow is basically going to be the real, like, large scale operation that you're essentially doing on Friday and Monday during the lab. Got a short video. This is made by one of Mr. Kelsey's AP Chemistry students. So it's showing you the pieces of the lab. These are all the materials that you're going to use during the lab. So you have a couple beakers, you got some HCl, you have some aluminum wire. We are using hydrochloric acid, so you're going to need goggles, obviously. That's our soil sample right there. You're going to take a scooped soil sample out. You're going to take the mass, see how much it weighs. That's your, that is your hole. You add some hydrochloric acid to it. The hydrochloric acid is going to draw the copper out of the soil and into a solution. So then what we're doing is we're taking some filter paper, put it in the funnel, and we are going to filter out just the liquid. That liquid is going to have the copper that we want. After we get that liquid, we're going to put an aluminum wire into it. The aluminum wire is going to get the copper back out of the solution. That's what you're seeing there. So all that reddish brown solid that you're seeing, that's all pure copper right there that we've isolated from the initial soil sample. Okay, so that's what we're doing Friday And then the second part about where you filter it out, that's going to be done on Monday.
Let's go.
Animated look at lunch.
Looks like it's the same as her.
Oh, yeah.
What a sweet mind.
Everyone else, you're going to learn some Minecraft apparently. Okay. Last thing, pre-lab. So this is some pre-lab questions that you need to complete for Friday as well. Just want to point out a couple things on here. It says, according to the nutritional information on the right, so from the Ruffles potato chips, what percent of a serving is fat? This is not the percent daily value, guys. Okay, I want to know what percent of that serving is fat, not how much percentage it is of your diet you need is fat, okay? So what you need to do is you look at the grams. So you see here, there's 28 grams in a serving. 10 of those grams are fat. So that's how you would figure out the percentage that's fat there. And you do the same thing for carbohydrates. I think there's a couple other questions there. It's self-explanatory. You guys should be able to figure it out, okay? If you have questions, we will be down on Science Pod 2. Or not Science Pod, sorry. Social Studies Pod. Okay? Is there any questions on pre-lab, percent composition, lab write-up, what you're supposed to be doing tomorrow?
If you guys still have questions about classes or anything else like that, please let us know. Specifically, I know I can speak on AP chemistry, electrical physics, but if you want to talk to any of us about any of the science offerings, I know some of these are already scheduled to go shortly, so I know it's important to say.
You have 7 minutes left right now. So get us started your percent composition worksheet, please.
What if you're